Welcome to Year 1 Mechanics, Chapter 10.3, where we continue to investigate and look into forces acceleration. Now, recall, we can work out resultant forces in two directions. Uh, X direction, we call it X direction, which is horizontal, parallel to motion, and Y direction, which is perpendicular to motion, which is usually vertically. Okay. Now, if you wonder, then you must have heard of some crazy parental method of teaching a kid how to walk down the stairs. One crazy way is to push him down the stairs so he can start, learn how to walk down the stairs. But you might be wondering, why is it harder to push a adult off the stairs compared to a kid? I'm not encouraging people to push people down the stairs. But one pose a question, why is it heavier? Why is it harder to push an adult? Well, here's the reason why. Newton's second law explains it because F of the formula, F equals ma. So F stands for resultant force. M stands for the mass. Now, the mass, the unit of the mass is kilogram. Okay, that's not the so weight is the Newton version of the is the weight version. Weight is the force version of mass. Sorry. So when we talk about how heavy are you, what's your weight? The weight we talk about in real life actually would refer to mass in science. A is acceleration. Acceleration is measured in meter per second squared, or resultant force measured in newtons. So obviously, okay, the heavier someone is, okay, if you want to generate the same acceleration, okay, now imagine if mass goes up, acceleration stay the same, then obviously the force you need to push it is higher as well to balance the equation. Or, okay, what if you want to keep the force the same? If you want to keep the force the same, then the heavier one person is, the mass goes up, then the acceleration has to go down. Okay, so if you push a person that's 2 times heavier than someone else, then the acceleration, assume you push with the same size of force, same magnitude of force, then the acceleration will be halved because double the mass means halving the acceleration. Okay, so that's why. All right. So yeah, so F equals ma. We'll be using this a lot. So let's have a look. A car of 3,000 kilogram has a driving force of 900 Newton and forces of 250 Newton resisting its motion. Work out its acceleration. So you can draw a little car if you want to. So draw a little if you want to. There's 2 wheels in this car. I don't know what car this is. It's not a motorcycle, but anyway. So has driving force. Let's say we go to the right. That's the convention. We go to the right. Okay. The car is 3,000 kilograms. The weight, force of 250 Newton resisting its motion. Now, if we're going to the right hand side, okay, a meter per second squared, then the resistance will be going to the left, 250 Newton. Okay. Now, I want to ask you, okay, what are the other forces acting on this car, regardless of driving force and the resistance force? There are 2 forces that are always there. The first one is reaction force. Okay, and down we've got the weight. Okay, the weight, okay, equals actually to weight equals to mg, which is 3,000 times g, which is not something you need to work out in this question, but it's useful to remember there's reaction and weight acting on the car when driving on the road. Okay, so work out acceleration. So let's use x direction. Okay, F equals ma. So F equals ma on x direction. So because the car is going to right, therefore the resultant force will be 900 minus 250, because car is going to right, equals the mass 3,000 times acceleration. So simple as it is. So 650 equals 3,000 A, divide 3,000 equals to 0.217 meter per second squared, 11.3 SF. Okay, right. Example: a child has a mass 50 kilogram. What is the gravitational force acting on a child? That is the weight. So if you have a child that weighs 50 kilogram, okay, oh, this should be standing on the ground. Then we've got 2 forces on the child. The first one is the weight, and this was the reaction. So the weight, we know the weight equals mg, equals to the mass 50 times the gravity 9.8, gravitational force 9.8, which is 490 Newton. So that's the weight. Okay. So why is it lighter on the moon? Because on the moon the gravity is only a sixth of the Earth's. So therefore, you will feel lighter on moon, and you can jump higher in on the moon. That's because the gravitational force is one sixth of the Earth. Okay. So the mass is the same. Whether you're on the moon, you're on Mars, whether you're on, I don't know, Saturn, you're on Earth, the mass is always 50 kilogram. But the weight is different because the weight takes account the gravitational force into account. Okay, right. Example, work on the missing force in diagram and the acceleration of the particle. You can see the particle is going to the right. Now you look at this diagram here, you realize there's a force missing in here. That's because this force is always the weight, 5g. Okay. So to work this question out, what we can do is we can look at it horizontally and vertically separately. So let's look at it vertically first. Okay, vertically. So y. Okay, let's use F equals ma. The force. Okay, so upward force, x, take away downward force, 3, take away 5g, equals the mass 5. Now, acceleration. Now you can see the acceleration is going to the right. Therefore, vertically, there's 0 acceleration. So I'll put in here first of all. Okay, a equals 0 vertically because particle moves right. Okay, you can tell by the arrow acceleration, the particle is moving to right. Okay, and this one, these are the upward force, take away downward forces. Okay, so it's always up, take away down, not always the case, but like in the future, you'll see examples where we don't always do up, take away, down. Sometimes we do down, take away, up. Depends on the motion of the particle. But anyway, but the particle in here, it's moving to the right. Therefore, upwards and downwards, the acceleration on the y direction is 0. Okay, so you can do x minus 3 minus 5g equals 0. If I rearrange it, you can see x will equal to 3 plus 5g. Essentially, you can write up equals down, which makes sense because if the particle is not moving up or down, then surely the forces pointing up should equal forces pointing down. Okay, so that also comes from F equals ma, the formula. So yeah, so on the y-axis, because the particle is not moving to up or down, therefore you can also write up equals the upward forces equals downward forces because they're balanced. So x equals, let's put in a calculator, 3 plus 5g. We know g is 9.8. Just put in a calculator, you should get x equals to 52 Newton. Okay, on the x direction, okay, let's use F equals ma. Now for the x direction, we can tell, 12 compared to 6. Obviously, right forces will be bigger than left. Now this is a given because for the particle to be moving to the right hand side, the forces on the right should be bigger than the left hand side, so that we have a positive acceleration going to the right. So because we're going to the right, so therefore we do 12 take away 6. The right forces take away left equals the mass 5 times acceleration. So in here, this is the right forces, that's the left forces. So 12 take away 6 equals 6, so 6 equals 5a. A equals 1.2 meter per second squared. Okay, right. So your turn. Okay, your turn. So pause the video. Have a go. Question 1 first. If you're confident, you can do both. I'll give you the answer for all of them. Okay, but have a go. If you're not confident, have a go. Question 1 first. When you're ready for the answer, you can press play. Here are the answers. Okay. So I'll go for question 1 first. Okay, gives you show the answer. If you got question 1 and 2 correct, move on. Okay, but if you don't, I'm just going to go for question 1 and give you a chance to work on question 2. So question 1. Okay, let's look at x direction. Okay, actually, before we start that, we know y has to equals 2g because y is the weight, 2g, which is the weight. So 2 times 9.8, which is 19.6 Newton. Now I'll put it in here because that's the weight. Right, regardless whether the particle is on the table, anywhere, if it's on Earth, there is always the mg, there's a weight. Okay, now, and then we can look at x direction, F equals ma. So it's all about using F equals ma, x, and then on the y. So in the x direction, there is acceleration. So on the x, we can see the particle is going to the right. Therefore, the resultant force is going to be 1 plus 15. So right forces take away the left forces equals 2a. So if you put in a calculator, you should get 16. So 3 A equals to 1.5 meter per second squared. So what about for the y? Now for the y, the two ways you can do it. One, you can set up F equals ma, where the acceleration is 0. So x, the resultant force is x, take away downward forces equals 2 times 0, because there's no acceleration on the y. Alternatively, because I know there's no acceleration on the y-axis, therefore the upward forces will equal to downward forces. Now, whether you rearrange it, you do left side method or the right method, you both get the same answer, where x, if you 2 times 0 is 0, plus y, you get x equals y on both of them. So x also equals to 19.6 Newton. Okay? So if you're happy with this, okay, pause the video, think about for this one. It's all about using x and y, F equals ma on x and y. So pause the video, have a go at the question. When you're ready for the answer, you can press play again. Now, first of all, we know x equals to mg. Because the mass is m, the g, well, we know weight, x is the weight of the particle, so weight is mg. So we know x equals 9.8 m. The question is, we don't know what m is. Okay, so what can we do? Well, let's work out horizontally. Okay, horizontally. Now, horizontally, F equals ma. Now, is there any acceleration horizontally? No, because you can see the acceleration is vertical. Therefore, if I do 3 plus 2 minus y for the force equals the m times acceleration 0. I'll put in here again, okay. 0 acceleration on x because particle moves up, because particle is moving up. Okay, so therefore we know 3. So y equals 3 plus 2, which is 5 Newton. Okay. Now, what about horizontally for y? F equals ma. The particle is going up. Therefore, the resultant force will be 10 minus the bottom force. 10 minus x equals the mass times acceleration 4. We know x is 9.8 m. So I'm going to write 10 minus 9.8 m equals 4m. So we can bring it over to the right side, 13.8 m, and then divide it over. So 10 divided by 13.8. Don't do the mistake of 13.8 divided by 10. It's still a mistake. 10 divided by 13.8, which is 0.725 kilogram. Once we know m, we can work out x. So x equals to 9.8 times 0.725, which is 7.105 Newton. Okay. Right. So next one, practice or example. If you're confident, okay, you can have a go at the question. Draw the diagram first. If you're confident, you can pause the video and have a go at the question. All right. But I'm just going to go through now. So a body of mass 5 kilograms. So what I'll do is, let me draw a diagram. Okay, 5 kilogram. Is pulled along a rough horizontal table. Rough means there's friction. Okay, there is friction. By a horizontal table, a horizontal force of magnitude 20 Newton against a constant friction of 4 Newton. So we know pointing to the right, we've got 20 Newton, and we've got friction to the left, 4 Newton. Okay, we know friction is towards the left because we're moving to the right. Okay, therefore friction will be against the motion. So the particle we know is going that way. Given that the body is initially at rest, find the acceleration of the body. So first of all, let's put in some forces. We've got 20 and 4, but also we know we should be putting down reaction pointing upwards and 5g. Now, for the mg, regardless of anything happening, okay, you should always have the mg. The particle is lying on the table, so there's a support given by the table, therefore the reaction. All right, so these two forces, when it's on the table, is always in there, R and mg. All right, find the acceleration of the body. So you can tell acceleration is going to the right. Therefore, there's one formula we use, is F equals ma. Which direction? X direction. So when you do the question about forces acceleration, it's always about using F equals ma. The question is X or Y? Well, judged by the question. The question wants acceleration on the X direction. Therefore, we use X direction. So we use F equals ma on the X direction. Okay, so particle is going to right, so the force will be 20 minus 4. Now, when you do F equals ma on the x direction, you must do the resultant force horizontally. Okay, so resultant force means the overall force. So 20 minus 4, which is 16, so the mass is 5a. So 16 equals 5a, a equals to 3.2 meter per second squared. Part B, find the distance traveled by the body in the first 4 seconds. Now, think about what topic, what thing do I have to do in here? Distance, time, suvat. All right, don't tell me distance equals speed times time. We don't use that kind of dummy formula anymore, the baby formula anymore. We use the suvat. So suvat. Okay. So distance traveled, that means we'll find s clearly. Time is 4. We know acceleration is 3.2. If you remember correctly, if you remember what I said about chapter 9 in the Suvat form, in the Suvat chapter, we need 3 pieces of information to use Suvat formula. We have 2, but we're missing 1. So surely we must know about U and V. Read the question again. Given that the particle, the body is initially at rest means U is 0. Initial velocity is 0. Okay, so use the formula without V. So S equals to UT plus a half AT squared. So S equals to 0 plus a half times 3.2 times 4 squared. So S, put the whole thing in calculator, 25.6 meters. Part C, find the magnitude of the normal reaction between the body and the table. Find the reaction in here. Now, if you didn't put in reaction, you probably don't know what they're asking you now. So reaction, part C. So it's all about, again, F equals ma in y direction. We know there's no acceleration on the y, so you can make r equals mg. So, or alternatively, you can do r minus 5g equals 5 times 0. So r equals 5g. So 5 times 9.8, which is 49 Newton. As you do more force equation, do more mechanics, you'll probably remember the 9.8 times table a lot because you'll be using a lot about 9.8 in mechanics. And I believe that's the end of chapter 10.3 about forces. You'll learn about new formulas today. F equals ma.